Okay, so I'm gonna go ahead and record how to look at this problem. I'll use a made-up one so that you can finish that worksheet. Let's see, number 4, part B. But basically, this is the question they're asking. From the graph, what values of x does y equal 0? So when you're looking at the graph, remember that on the graph, y equals 0 right here on the x-axis. So we want to know where does the graph touch the x-axis? And remember, these are called the x-intercepts. And there's actually a lot of names for this. Another name is a 0 because y equals 0. But that's what we're looking for. So how does this look? So remember before, I'm going to set up the graph. So I'm going to take this equation, create a table of values, x and y, and let's create our graph. So I'm going to kind of try to keep it not too far out. Let's go -2, -1, 0, 1, 2, 3. Let's see if that's enough points to graph this pretty well. So if I plug in -2 to this equation, that's going to give me a 4 right there. So that'll be -12 minus 4. So that'll be -16 plus 7 is 9. So at, let's see, at -2, would that be 9? Let's see, 4. So that would be -12, -16 plus 7 is 9. Yeah, that should work. Oh, -9, I'm sorry. I dropped off the negative because I did it in my head. So we have a point at -2, -9. So if I'm going to draw that and go 1 per box, I probably need to extend that out. Okay. And remember, as you're doing this, the cool thing is, if you know your axis of symmetry, you only need one side's points. So I'm going to let me show you that trick too. Okay, so let me label this. This is a really cool little trick. Speeds things up. But I haven't done this specifically in this detail in a while. That's why I forgot. So we're going to use that x equals -b/2a to get the axis of symmetry. So a is -3, b is +2, c is 7. So I'm going to plug in -3 on the bottom there, and I'm plugging 2 on the top. So x equals -2/2 times -3. And look at this. We're going to get a fraction. This is actually going to become x equals, the 2's are going to cancel. The negatives are going to cancel. This is 1/3. X equals 1/3. Our line of symmetry is at 1/3, like right there. So this is going to make a funky looking graph. And for us, that means that we're not going to have precise mirrored points like we have in the past. It's going to be a little bit more challenging, but it's very close to the y-axis. So whatever's on this side should closely match what's over there. It's just off by a little bit because of this axis of symmetry. Let me go ahead and mark that. And it's not actually part of the graph, except at the vertex where it touches this. And this is negative, so I know it's going to go like this. So somewhere up here, it's going to touch it. Hopefully I put that far enough up, but that's a 7. I think it's definitely going to have to go up there a little further. But anyway, so we know it's going to go like this. My first point is at -2, -9. 1, 2, 3, 4. Here's -5, 2, 3, 4. Here's negative 10. So negative 2, negative 9 is right there. All right, let's keep it going. If I plug in a negative 1 here, negative 1 times negative 1 is 1. So this is negative 3. This will become negative 2. So all that's negative 5 plus 7 is 2. So our next point is at negative 1, positive 2. Then our y-intercept, if you plug in a 0 here and here, it's going to become 0, and all you're going to have left is the 7. So the y-intercept has to be 7. So this graph will cross at 7 up here. 1, 2, 3, 4. Oh, no, wait. 1, 2, 3, 4. Right here. And let me make those really big so you could see them. So here's our y-intercept, but this is not the vertex. Not necessarily, right? Especially because the line of symmetry is a little bit further. So the vertex is just a little bit further. It's going to be just a little bit higher than 7. But our peak is really close here. All right, so let's get a few more points on the other side. If I plug in a 1 up here, I'm going to get negative 3, because this, 1 times 1, you could do that a million times, it's still 1. So this will be negative 3 times 1, negative 3. 2 times 1 is 2. Put that together, you get a negative 1. Add that to 7, and you get 6. So now I have the point 1, 6 right here. So you can see that 2/3 of the way, it's already dropped this much. So I would guesstimate that the vertex is probably about right here. And I'm going to go ahead and draw my line like that. And you can see right here that this first x-intercept right here is just a little bit past 1. So here is an x-intercept. Just a little bit past 1. So we could estimate that that x-intercept is, it's a little bit past 1. I don't know how much. I'm going to go 1.2. I'm going to say that's about negative 1.2. I'm sorry, because it's on the negative side. Because it's right between this negative 2 and this negative 1. Now, let's finish it off over here. We need to get a little bit more direction over here. I don't want to do this without having some points down here that tell me where to go, because I had those already over here. So let's get 2. When I plug in 2 up here, that's 2 times 2 is 4. Times negative 3, this will be negative 12. 2 times 2 is 4, so negative 12 plus 4 is negative 8, plus 7 is negative 1. So the y-coordinate when x is 2 is actually down here. Ooh, that's nice, because it gives us a direct run. And it's probably going to go, remember, it's going to do its little curve thing. It's not going to get all the way to 2, because it can't. It has to be a little bit before 2, but it's going to be pretty darn close. So that could be, like 2.9. Here's another x-intercept. And it is so close to hitting 3 right there, I would say that's about 2.9. So we can estimate the x-intercepts are about negative 1.2 and 2.9. And their estimates, they don't have to be perfect. Okay, and remember also, you can identify these because right here, the y-coordinates switch from positive to negative because it switched from positive 6 to negative 1. And because this is so close to the 0, we know it's going to be close to 2. If it's close to this one, it's going to be close to this one. And then up here, we switch from negative 9 to positive 2. It's going to be closer to negative 1 than it is to negative 2. So you can also use the table to figure those out. And finally, these would also be estimates of the solution. And if you really want to know what the solution is, since this is not precise, use the quadratic formula or factor. But because this is a decimal, I would say use the quadratic formula to get the precise result. Okay, and I hope that helps.